Hi everyone, welcome back to MediC Academia. So we are still in calculus. Please don't forget to like our videos, share so that others can be able to benefit from this tutorial. So now we have done a lot of functions, a lot of methods. We have talked about using the general method, how to use the first principle, the quotient rule, the function of functions, exponential functions, logarithm function as well. So now the one we are going today is trigonometry functions. That one's another way, or that's another method under the differentiation. So how are we going to talk about that? So there are some things that we need to learn before we even go for any other approach. If I have y is equal to sine x, for example, let's say we have y is equal to sine x. So the norms, differential of sine x is always cos x. This cannot be changed. If you are doing differentiation in this case, whenever you have sine x, differential of sine x is always cos x. Or let's say we have y is equal to cos x. So here, differential of cos x is nothing but sine x. So please, you have to master this identity whenever we have sine x. Before that, there's an identity. In case if you missed our previous video concerning trigonometry, we talk about some identity like that. If you have sec x, we said sec x, or let me write it here because we need them. We said if we have sec x, whenever we have sec x, or let's say we have sec x is nothing but 1 over cos x, and whenever we have cosec x, that one is nothing but sin x. All this identity, you have to master them, please. This is not a differentiation, but it's just a normal identity that we have in math. When we have sec x is nothing but 1 over cos x. Whenever we have cosec x is nothing but 1 over sin x. And whenever we have cot x is nothing but 1 over tan x. All these identities, they are very, very important. And I told you that when we have tan x as well, it's nothing but sin x over cos x. And when we have cot x, it's also cos x over sin x. So in case you can see the way I'm writing all those identities, in case if you miss the videos on trigonometry, the one we talk about in Math 101, you can just check so that you can master all this identity. When we have sec is nothing but 1 over cos x. When we have cosec is nothing but 1 over sin x. When we have cot x is nothing but 1 over tan x. And when we have tan x as well, it's nothing but sin x over cos x. And when we have cot x, is nothing but cos x over sin x. So all these identities, and there's another one, the one we use in general, that we said sin square x plus cos square x. This is nothing but what? This is nothing but 1. So this identity too is also important. All the identity that we mentioned so far, we have to be monitoring them so that we know how to make use of them one after the other. So now under differentiation, under the trigonometry functions, if I have sin x, it has a proof. If you check our materials, you see how we prove that. So differential of sin x is always cos x, and at the same time differential of cos x is nothing but minus sin x. So this one can be twisted in many ways. Let's say we have, okay, for example, let's look for if it is different from sin x or cos x. Let's say they say if y is equal to tan x, and they said find dy dx. Now it's not sine, at the same time it's not cos now. So how are we going to find the derivative of this? From here we said tan x is nothing but sin x over cos x. So if I come here, I can have y is equal to, instead of saying tan x now, we are going to have sin x all divided by cos x. Just an identity. We have not differentiated. Now recall that when we have a fractions, when we have a fraction, when we have numerator and denominator, we say the method we can apply is what? Yeah, quotient. So I can see this is my u, at the same time this is my v. So which means u is equal to sin x and v is equal to cos x. So I will differentiate the first one and I will differentiate the second one. So u and x, and we have du over dx. Normally we know differential of sin x, we are going to have cos x. So here v and x, and we have dv dx is equal to differential of cos x, we are going to have minus sine x. So we have gotten du dx to be cos x, and we have dv dx as well to be minus sine x. So now recall the formula for the quotient. When we have a formula for the quotient, I hope you remember that. For the quotient, we know the formula is dy dx is equal to v du all over dx minus u dv over dx, all divided by v squared. Remember this formula for the quotient? Yeah. So here we have dy over dx is equal to v. Our v that we have here is cos x. We have cos x du dx. So our du dx we have here too as well. It's also cos x. We have cos x minus u. Our u that we have here is sin x. We have sin x. Dv dx that we have as well, we have the dv dx to be also what? Minus sin x. Minus sin x, all divided by v squared. Our v that we have here is our cos x. That means that we have cos x all square. If you have cos x all square, it's nothing but cos square x. So here I can have dy dx is equal to cos x multiplied by cos x. Of course, we are going to have cos square x. Just like we are multiplying the two together, cos x multiplied by cos x, we are going to have cos square x. Then this is minus, this is also minus. Minus times minus, we are going to have plus. Then sin x times sin x, and we have sin square x, all divided by cos square x. Or you can say cos x all square, or you can say cos square x. You see the same thing? So now, it's like if I have a plus b, if I have a plus b, it's still the same thing as a b plus a. So what am I trying to say here? If I have cos square x plus sin square x, of course, it's nothing but sin square x plus cos square x. So that means here I can have this to be dy dx is equal to, so instead of writing this, I will just write sin square x plus cos square x, all divided by cos x all squared. There's another identity that if you have sin square x plus cos square x, it's going to be equal to what? Yeah, 1. This is dy dx is equal to, so sin square x plus cos square x, we are going to have 1 divided by cos x all squared. So recall, if I have 1 over cos, we say if you have 1 over cos, is nothing but what? But sec. So that means here I can have dy dx of this to be equal to sec square x. You see that? Yeah. So that means differential of tan x, the result is always a sec square x. I will do one more so that you see how. So now let's add the identity here. The first one we said, if you have y is equal to sin x, so differential of sin x, we say that one is cos x. And if you have cos x, differential of cos x is nothing but minus sin x. And we say if you have y is equal to tan x, then dy dx of this is nothing but sec square x. So now let's see another one. Let's say I want to find the derivative of sec x itself. So let's see that. Just have to master the identity. Once you master the identity here, you don't have any issues because they are all simple and straightforward. Let's say for the first one, let's say we have y is equal to sec x. Let's say I was asked to find the y dx of this one. So I will still go along together with the same method or the same pattern. So I know if I have sec x is nothing but what? Yeah. So that means here I can have this one to be y. So instead of writing sec, I'll just have 1 over cos x. Get that? So this is, since you have fractions, this is going to be u, and this is going to be v. And I will still use the same approach. So now, that means our u is equal to 1, the one we have at numerator. Then our v is equal to cos x, the one we have at our denominator. So now u and that is du dx. Normally we know differential of a constant is always what? Always 0. So here v and x, and we have dv dx is equal to differential of cos x. We are going to have minus sine x. You remember that, right? Yeah. So now, so I can have the formula now. dy dx is equal to v du all over dx minus u dv all over dx, all divided by v squared. So here we can have dy dx is equal to v, our v is cos x, du dx that we have is 0, minus u, the u we have is 1, dv dx we have is a minus sine x, all divided by v squared, we have it to be cos x all square. Just making simple substitutions. V is cos x, du dx we have it to be 0, then minus u is 1, then dv dx we have it to be minus sine x. So cos x times 0, of course, we are going to have 0. So here I can have dy over dx is equal to cos x times 0. You know that one is going to be 0, right? So now minus times minus, and we have plus. So 1 times sine x, what we have left is as sine x over cos x all squared. You know, the meaning of this means that the value that we have here is 2 now, is 2. That means we have 2 cos x. So that means here I can write this as I can say this is nothing but 1. Anyhow you like it. I want to break this one into 2. Anyhow you put it, it's still the same thing. I can say this is nothing but sine x over cos x multiplied by 1 over cos x. You get that? The first one, sine x over cos x for the first one, then times 1 over cos x. So we know if you have 1 over cos is what? Identity. If you have sine x over cos x, as I told you earlier, is nothing but tan x. The only thing that we need here, just try to master the identity. If you master the identity, then you are good to go. So now, sine over cos, and we have tan x, then 1 over cos, and we have sec x. You see that? So that means the differential of sec x is nothing but tan x sec x. The only thing that matters under the logarithm, under the trigonometry, is the identity. How are you going to transform the identities, even apart from being define its derivative? So differential of sine x is cos x, and differential of cos x is what? Minus sine x. So let's see some examples. Let's see some examples and how we can approach them. Here they said if y is equal to sine 2x squared plus 5, they say find dy dx. You can see it's different from the first one. You know, if it is just x that we have there, we know differential of sine x, that one will give us cos x. So, but the only difference here is that we have a value in the bracket, but it's still the same thing. How are we going to do that? Recall that we have talked about the function of functions. You remember that? You say as a first thing, you just say let any alphabet of your choice to be what we have in the bracket. You can use k, so far it's not y and x. You can use anything. So now let me use u. Let u equal to what we have in the bracket, which is 2x squared plus 5, right? So if that one is u, that means that we have y is equal to sine u. Can you see that? I just let my u to be what we have in the bracket, let u to be equal to this, then y is equal to sine u. So this is u and x, and we have, you can see this is u, and this is x, then we have du dx equal to differential of 2x squared, of course, we are going to have 4x, and differential of 5, that one is nothing but what? But 0. So here we have y and u, that means that we have dy all over du equal to differential of sine, just like differential of sine x and differential of sine u, that one is nothing but cos u. Get that? So therefore, dy dx will be the first value multiplied by the second value. That is du dx multiplied by the second value, which is dy over du. So here we can have dy dx is equal to, so du dx we have is 4x multiplied by, so dy du we have is cos u. So now 4x multiplied by cos u, of course, and we have 4x cos u. But from here, we know that our u is nothing but 2x squared plus 5. So here we can have this one to be 4x cos. So instead of writing u, I'll put the value of u, which is 2x squared plus 5. But let's assume that you come across this type of question in objective text. You need to use the long method. See the way of the short one. So see the way I will do this short method. The way I will do the short method. The first step is differentiate what we have inside that bracket. Differential of 2x squared, of course, and we have 4x, right? And differential of 5, that one is 0. So we know differential of sine is nothing but cos, then you repeat the values, 2x squared plus 5. You can see, if you check, they are the same. Let me explain that short method again. Differential, just go back to what you have in the bracket. Differential of 2x squared, of course, we are going to have 4x. So differential of 5 is 0. That's why I did not include that one. There are no differential of sine is cos, then repeat the angle that we have there. So now you can see if you check the short, if you check the long method and check the short method, you can see the two are the same. So now let's see another examples. Let's look at the question from our Federal University uses materials. The question says that differentiate the following, find the derivative of the following, find the derivative of the following. One, y is equal to sine 5x 2, y is equal to tan, okay, I think we have done that one, x squared sine 2x 3, okay, cosec x 4 cos 7 4x sine x over 1 minus 2 cos x log sine 2x plus 1. So let's take a look at them one after the other so that we know how to approach all those problems one after the other. Now, so from the first one, in the first problem we say we have y is equal to sine 5x. The first problem, we say we have y is equal to sine 5x. You know, this one too, just a simple method, a simple approach. Y is equal to sine 5x, just like what you did here. We can just quickly use that approach. So here I can have the y over the x is equal to, now differential of 5x, you know, differential of 5x, that one is nothing but 5, right? Then differential of sine, I know that one is cos, then repeat the angles back, 5x. Can you see that? This is just the short method. You can see the long, let's say you can, if you find this type of problem in objective text and theory text, let's say the y is equal to sine 5x. So since it's not in numbers, since it's not just x, use, let's say let u equal to 5x. So if that one is u, then that means that we have y is equal to sine u. You get that? So the first one, u and x, and we have du over dx is equal to the differential of 5x, and we have 5, right? So y and u, and we have dy du equal to differential of sine u. Of course, we are going to have cos u. So therefore, dy dx is equal to the first one multiplied by the second one, which is du dx multiplied by dy du. So du dx that we have is 5. Dy du that we have is cos u. Can you see that? So our u from here is 5x. So that means here we have 5 cos 5x. So anyone you use, you can see, since the value is not much, either use the first approach, depending on the problem you are solving. If it is theory objective, if it is theory text, use the second one. If it is objective test, then you can use the first one. You can see it's very short and precise. Just differentiate this one, differential of the then put back what you have initially. So let's see the second questions. They said, so in the second one we have, what we have, y is equal to x squared sine 2x. You can see here we have two functions. So don't forget, if you have a two function, what method are we going to apply? Yeah, we're going to apply the product since we have two. So here you can see, let this one be u and let this one be v. That is, this first one is going to be u, just like product rule. So let u to be x squared and let v to be sine 2x. So what do we do here? We let u to be the first one and we let v to be the second one. So here we have u and x, and we have du dx is equal to differential of x squared, and we just have 2x. So here and we have dv dx. Don't forget, this one too is not ordinary x. So just like the short method I applied earlier, differential of 2x, and we have 4, right? Differential of sine, that's going to be cos, then we repeat the angle back 2x. I hope you get that right. So we have du dx to be dx, and we have dv dx to be 4 cos 2x. So what is the next step now? The next step is to multiply them together using the formula for the product. These are dy dx is equal to u dv dx plus v du dx. So from here, what we have for u from here is x squared. So I can have x squared. dv dx from here is 4 cos 2x plus v is sine 2x. Then du dx from here is 2x. 2x here. So it depends on how they leave the results. So you can check what we have in common to the two. You can see we have x squared here and we have 1x here. So that means x is common. If I bring it out, so here we have 4x. Even if we have 2 in common, because 2 can be in 4. So that means I can bring 2x. So the moment I bring 2x, here now we are going to a level with 1x, and 2 in 4, and we have 2x. Can you see that? So now, then we have the angle cos 2x plus, we have already bring out the 2x. What do we have left here? We have sine 2x. Can you see that? Yeah. Now let's look at this one too. They said y is equal to cosec x. So it's still the same thing. I told you earlier that each angle we have, apart from sine, cos, and tan, they have their identities. Just know how to use the identities. So let's see that one too as well. You see? Yeah, no. When I did not raise my voice, have you? I'm just tired. I just need rest. You want to give him a tea? You want to give him a tea now? I'm cool, right? It's good to be cool sometimes, brother. Now, so now don't mind me, let's go for the second examples. I'm talking to my lovely brother here and our manager that make this thing to be more convenient for us so that you people can be able to learn from us. So now, so y is equal to cosec x. Y is equal to cosec x. You see, the cosec x is just the first thing to do is to remember the identity that we know, cos. Cosec is nothing but what? Yeah, so that is y is equal to cosec is nothing but 1 over sine. Just like the way we change sec. I would say sec is nothing but 1 over cos. So when we have cosec, is nothing but 1 over sine. So now we can use quotient approach now. This is going to be our u, this is going to be our v. So that means u is equal to 1, v is equal to sine x. So now u and 1, now we have du dx is equal to 0 because differential of 1 is going to be 0. V and x, and we have dv dx of this to be equal to differential of sine x. Of course, we are going to have cos x. You get that? So du dx is 0. dv dx is cos x. So now let's use the normal method. dy dx is equal to v du all over dx minus u dv all over dx, all divided by v squared. So now let's input the values one after the others. So that means that we have dy dx is equal to v. You can see from here our v is sine x. I have sine x. du dx that we have is 0. So we have 0 minus u. Our u we have is 1. dv dx we have is cos x. Then all divided by v squared. The v that we have is sine x. So that's what we have here is sine x all squared. So now I can have dy dx to be equal to, now sine x times 0, you know anything times 0 we are going to have 0. The minus 1 times cos x, of course, we are going to have minus cos x over sine x all squared. So meaning of this means we should break this down into 2. So that means here I can have minus, so let's break it down into 2 now, because this one just like a square, just like the way I break for sec. This is nothing but cos x over sine x 1 over sine x. So how did I do that? You know this one is a square. You know, sine x and sine x, of course, you are going to have sine x all square or sine square x. So remember this identity. If I have cos over sine, is nothing but cot x, and if I have 1 over sine, is nothing but cosec x. So that means differential over cosec x, the result is minus cot x cosec x. Get that? Yeah, fine. So let's check the next questions. The next question says that, look at the next one. Number 4, they said y is equal to cos 7 of 4x. You see, this one is just a packaging. So how will I go about that? I can write this as cos 4x whole raised to the power of 7. You get that? Now, fine. So let the first step, let u, just like using function of functions, let u to be equal to what we have in the bracket. This is cos 4x. So if this one is u, that means that we have y is equal to u raised to the power of 7. So u and x, and we have du dx is equal to, just let's do that short method. Differential of 4x, you know, we have 4. Yeah, differential of 4x is 4. Differential, of course, we know that one is nothing but sine. Then differential of the result that we have, let me just explain this step again so that you get it better. Differential of 4x, we know that one is 4, right? Now, good. So we know differential of cos is what? Minus sine. Good. Minus sine. Then repeat the angle back. That is 4x. So that means the UDS of this one is going to be minus 4 sine 4x. So y and u, and we have dy du as usual. That's going to be 7 u raised to the power of 6. So therefore, apply the formula. Dy dx is equal to, since we use function of function chain rule, the first one times the second one, which is du dx multiplied by dy du. So the first one we have here is minus 4 sine 4x multiplied by the second one we have is 7u raised to the power of 6. So now minus 4 times 7, you are going to have minus 28 sine 4x, then u raised to the power of 6. So but our u is something here. Our u is cos 4x, so that means here I can have, we are going to have minus 28 sine 4x u. What's our u here? Our u is cos 4x raised to the power of 6. Can you see that? It's just so simple. Now let's take a look at the next questions. Take a look at the next questions. Have you seen Doctor? No. Yeah, it's a guy. I saw his car. Yeah. So y is equal to, so y is equal to sine x over 1 minus 2 cos. You can see this one too. Since we have a fractions, the only method we are going to apply is which one? Yeah, we're going to apply quotient. So if I apply the quotient here, so as usual, this is going to be our u, right? And this is going to be our v. So that means here u is equal to sine x and v is equal to 1 minus 2 cos x. So after that, u and x, here I can have du dx is equal to differential of sine x, and we have cos x, right? Then v and x, and we have dv dx is equal to, but you know, differential of 1, that's going to be 0. So minus 2 differential of cos x is going to be what? Yeah, minus sine x. You get that? So here we have dv dx of this is equal to minus times minus, and we have what? Plus 2 times sine x, we are going to have 2 sine x. So that means du dx is cos x, dv dx is 2 sine x. So from the formula we know for the quotient, dy dx is v du dx minus u dv dx all divided by v squared. So let's substitute the values one after the other. Our v we have here is 1 minus, this is what we have for v. Our v is 1 minus 2 cos x. Du dx is cos x minus u. Our u we have is sine x. U we have is sine x. Dv dx, you can see, dv dx we have is 2 sine x. 2 sine x. Then all divided by v squared. Our v is 1 minus 2 cos x. 1 minus 2 cos x all squared. Can you see that? Yeah, good. So now let's open the bracket with this. So if I open the bracket, 1 times cos x, of course, we are going to have cos x. I'm opening the brackets now. Cos x times this, and we have minus 2 cos square x minus times this, and we have minus 2 sine square x. You can see. So what did I do here? I only open the bracket. 1 times cos x, we are going to have cos x minus 2 cos x times cos x, and we have minus 2 cos square x minus sine x times 2 sine x, and we have minus 2 sine square x. Then all divided by 1 minus 2 cos x all squared. So here we have this result to be, it's like I want to combine this together. You can see, or let's factor something out from here. I can have cos x. So if you check this from here to here, what do we have in common? 1 minus is common. What again? 2. Good. So then if I do that, you know, what we have left here is cos square x plus sine square x all divided by 1 minus 2 cos x all squared. So now you can call, you know, if I have cos square x plus sine square x, it's the same thing as if you have sine square x plus cos square x. And remember, we call from the identity, sine square x plus cos square x is nothing but what? But 1. So that means there I can have that one to be, so there I can have this one to be dy dx now is equal to cos x. So that one I can have the result now to be minus 2 1. You get that? All divided by 1 minus 2 cos x. You get it? So now this is just the same thing as dy dx is equal to cos x minus 2 divided by 1 minus 2 cos x all squared. So just what matters most is the result that we have. Let me explain this one again. So our v is 1 minus 2 cos x. Du dx we have it to be cos x. U is sine x. Dv dx we have it to be 2 sine x over 1 minus 2 cos x all squared. So when I open the bracket, cos x times 1, I have cos x. Cos x times this, I have minus 2 cos square x. Minus 2 times this, I have minus 2 sine square x. Then we have this. In fact, you can see minus is common to the 2. We bring it out as well. 2 is also common. I factor it out. Then what I have left is cos square x plus sine square x. Then from the identity, we know sine square x plus cos square x is nothing but 1. So we have this one to be 1. Then we have cos x minus 2 divided by 1 minus 2 cos x all squared. So those are the things So I'll just explain this one since we have known a logarithm function before. Under the logarithm is nothing but when we have a function, it's going to be dy dx. That's f prime of x over f of x itself. You remember? Yeah. So here, if I let f of x to be, what do we have there? What we have there is a sine 2x plus 1, right? So here, let f of x to be this. Then if I have f prime of x, what's going to be our f prime of x? Yeah, so differential of 2x, that's going to be 2. Differential of 1, that's 0. Then differential of sine is cos. Then we have 2x plus 1, right? You get it right? Fine. So now, with the formula, dy dx is equal to f prime of x over f of x. So now, I can have dy dx to be our f prime of x, we have it to be 2 cos 2x plus 1 divided by f of x itself, we have it to be sine 2x plus 1. This is just another identity. If I have cos over sine, that one is what? Yeah, it's tan. So we have tan. If I have, sorry, it's cot. If I have cos over sine, if you have sine over cos, that one is tan. But if you have cos over sine, that one is cot. So here we have cot 2x plus 1. So that's all about what we have. It's not there again. Yeah. So that's what we have in this. Hmm? Okay. So that's what we have for this case. So any question you see related to trigonometric functions, just know how to treat the identity, then you apply the method.